A lot of people think that oil and gas are found inside ponds or lakes underground, which is not true. In this video, we are going to illustrate the occurrence of oil and gas and how can we recover them. The main theory states that organic remains are buried millions of years ago underground in a high temperature and pressure formation. These conditions promote the decomposition of organic matter and we get oil and gas. The formation in which oil and gas is formed is called formation rock. Now, the oil and gas are found in a high pressure zone, and as fluids, they try to escape to a lower pressure zone. This is the formation in which oil and gas occur. And as we said, it has high pressure. So fluids tend to move to a lower pressure zone. However, fluids do not find the pathway up to the surface, and they are trapped under sealing rocks or cap rock. There are two main properties indicating the type of rock: the porosity and permeability. Porosity is the percent of void spaces inside the rock. So, if we have a core sample that is cylinder in shape, and we know the diameter and height of the sample, then we can get the volume of the sample. Now, we want to calculate the volume of the pores so we can get the porosity. The easiest method is the saturation method, in which we saturate this rock with water or a known fluid. So we submerge this core sample inside water, for example, and wait until it is saturated with water. So if we want to calculate the mass of water absorbed, it's going to be equal to the mass of the sample after saturation minus the mass of the dry sample. The volume of the water absorbed is equal to the mass of the water absorbed divided by the density of the water absorbed. So now we can calculate the porosity of the rock sample. And permeability is the ability of the rock to move fluids between its interconnected pores. So migration rocks have high porosity and permeability, and cap rock have low permeability and porosity. Permeability and porosity do not only tell us things about rocks, but also about reservoirs. We have conventional reservoirs in which we can get oil and gas flowing from the reservoir up to the surface, and unconventional reservoir which has very hard conditions to get the oil and fluid from inside the reservoir up to the surface, and it requires hydrocracking and other operations that we are going to illustrate in upcoming videos. Let's get back to our illustration. Now, this is the formation in which oil and gas is trapped. Of course, they are layered according to difference in density. So, we will have water, oil, and gas. We only need to provide a pathway for these fluids so they can escape from high pressure zones. Think of it as if you have a sponge filled with water and you want to get the water out from the sponge. What are you going to do? You're going to squeeze the sponge. By doing so, you are creating a high pressure zone inside the sponge, so fluids can migrate from inside the sponge outside. We have the same thing in the reservoir. However, the reservoir pressure is very high and we only need to create a pathway up to the surface. And here comes the importance of drilling rigs. They create a hole so we get a pathway for fluids from inside the reservoir up to the surface. And of course, we're going to talk more about drilling rigs and drilling rig components in upcoming videos. We have three main recovery methods: primary recovery, secondary recovery, and tertiary recovery. In primary recovery, what we're going to use is the difference between the reservoir pressure and the atmospheric pressure. So we rely on the pressure of the reservoir. However, after some time, the reservoir pressure becomes insufficient to provide the delta P needed for fluids to move from the reservoir up to the surface. Here comes the secondary recovery. And finally, when secondary recovery becomes uneconomic, we start to utilize other methods to alter the properties of the oil. If you want to know more about these techniques, make sure to subscribe and to follow this channel, because we're going to talk about all of these processes in depth in upcoming videos. Thank you so much and see you in the next video. Goodbye.